In this tutorial, we're going to learn how we can do logistic regression in R. There are 3 parts of R code we're going to go through. Let's just focus on the first part first. So the first, we're going to read the data from this link, and then we'll print out the data. So I will post all this code in a link down below in the video, and then you can run this R code by yourself to do some practice. Okay, so let's run the first line of code first. So basically just read the data into this variable, and then you can print out the data. As you can see that there are 4 columns of data. The first column is admit, is 1 and 0. 1 means that students got admit to the graduate school. 0 is not got admit. And this is the GRE and GPA data, and that's ranking data. And we're not going to look at the ranking data. We're going to just focus on the GRE and GPA. So the model is that this is dependent variable, this is independent variable, this is another independent variable. So there are 2 independent variables in the model. So since that dependent variable is 1 and 0, so this is the logistic regression. And now we move to the part 2, which we're going to write out the model statement. So in the model statement, this is a dependent variable, and these 2 are 2 independent variables, and this is the data. And this tells them that this is the binary logistic regression. You say this into this result, and then this is the result summary. We can run these 2 lines of code to see how they looks like. So this is the output, and we're going to focus on the regression coefficient. And for this, we can write out the model statement. So we can actually write out a model statement. Remember that this is logistic regression, so the dependent variable in this statement actually is a log os. What do you mean by saying log os? It's the log of the or it means that probability of got admit to graduate school divided the probability of not got admit to the graduate school. So this is called log os, and then equals the intercept, and then the B1 is the regression coefficient for the GRE, and the B2 is the regression coefficient for the GPA. So this is from the R output. We just put just write out the statement based on the number that output. And what do these 2 regression coefficients mean? That means that, okay, for GRE, you increase GRE for 1 unit, the log os increase 0.003. And in the GPA increase 1 unit, the log os increase like 0.755. Just a side note, this is hypothetical data, so we just use this data to learn how to do logistic regression, so don't read too much in terms of the result. But anyway, now you get the idea how to write out this logistic regression model statement. Now we're going to move to the part 3 of this tutorial. The basic idea is that actually out of the part 2, we basically can say that we are done with the logistic regression because we already can write out the prediction, the estimate model. Yes, we can estimate the regression coefficient already. But sometimes you want to use this estimation, the model we estimate, and then we want to use them to test using the new data. For this, we create a data frame. This data frame statement is a bit long, but so let me run this statement and to print out the data to show you how the data set looks like. So we run this line more, and we run another print out. So this is how the data set looks like. So we print out the new data, this new data frame. So basically, it only has 2 columns of data. One is the GRE and GPA, and there are 20 rows of data. And the first 10 and the second 10 for the GRE, they are the same. So so as you can see that the GRE from 220 to 800, and there are 10 of them. So the reason why we chose these 220 and 800 is because in the observed data, so we can summarize the observed data, see how it looks like. The observed data was GRE. So this is the data we read from this file, and you can see the minimum number is 220 and the maximum number is 800. So that's why we chose that as a range. So as you can see that the first one is 220 and the 11 is also 220. So we kind of like, as you can see that for GRE, it just had 2, first 10 and second 10, they are the same. And for the GPA, we chose the first 10 is all other than 4. The reason we choose the 4 is because the 4 is the highest GPA, and another is 3.38. This is the mean of the GPA. So that's why we generate this new data set. And then we can use the model we estimate to run some predict. How can do that? You use the predict function, and this is the logistic result. That's where we say the estimate. So this we save all the estimate regression coefficient, and then the data. Now we use a new data, and then the type response. So that will return the probability. So and then we say the probability as a new column of data. Let me run this, and then you can see how it looks like. So as you can see that compared to the earlier, the new data frame, we have another additional column of data, which is the probability of students got into the graduate program. And to better get the idea like how this data set looks like, we can actually plot that, use the ggplot. So this is the plot function. The plot is here. This is the figure, the plot. It's a relation between these 3 columns of new data. Yes, this is GRE from 220 to 800. This is the probability of getting to graduate school, and this is the GPA. The red line is the GPA, which is 3.39, and the blue line is the 4 GPA. So it kind of makes sense that you have 4.0 GPA, you have greater chance. Yes, so we can see that the blue line is above the red line. And also makes sense, you have greater GRE, your chance of get into graduate school also should be higher. Yes, so this is what this figure means. It kind of visually shows us the relationship of these 3 variables within the new data frame. I think that's it. Thank you for watching. If you find this tutorial useful, please like and subscribe. If you have any questions or comments, feel free to leave a comment down below in the video, and see you in the next tutorial.